Good afternoon, everyone. Hope everybody is staying safe during this lockdown. I thank everyone for showing their interest in this webinar on iSystems. I am Vikas, working as a product sales engineer at Trident Infosol. Before we get into the webinar, I'd like to give a small introduction about our organization. So, we started in the year 2000. Trident Infosol stands for the name Complete Solution Provider. We have a corporate office at Bangalore, registered office at New Delhi, and other branches at Mumbai, Chennai, Pune, and Ahmedabad. These are some of our partial client lists that we have displayed. We operate on majorly three verticals: COTS order solution, COTS software solution, and the system solution. With these verticals, we help to serve industries such as aerospace, automobile, defense, etc. In the COTS hardware solution, we provide single board computers, rugged laptop for defense purpose. These are some of our partners for the COTS hardware solution. In the COTS software solution, the division where I belong, we provide a complete solution from the requirement till the validation and testing stage of the embedded V cycle. The first phase, the requirement phase, we have Rectify, which is a requirement traceability and capture tool. No Magic is a software modeling tool. ArgoSim is a requirement simulation analysis tool. Innova is a PLM software. The second phase, the design phase, we provide model-based design software like Daimola, reliability analysis and simulation software like RAM Commander, and the libraries for model-based design software like Modelica libraries. In the third phase, we have development. We provide solutions like IDEs, compilers, debuggers, where iSystem comes into picture in this phase. And the fourth phase, we have verification and validation, where we provide software testing tools and hardware in the loop solutions. The fifth stage, we have testing and measurement. These are the partners for the COTS software solution, where iSystem is our key partner. The third is a system solution, where we provide display consoles, rack and enclosures for the defense, which are manufactured in-house in our organization. In terms of capabilities, we are AS9000 and Semilac certified labs, where we run tests like thermal chambers, drip test, PCB power supply test, etc. I am now handing over to Mr. Ailes Hoser from iSystem. Ailes works as a field application engineer at iSystems and comes with 20 plus years of embedded software development experience.
Welcome everybody to the iSystem webinar Continuous Integration. Some information upfront before Alesh starts. During the webinar, you are all muted. Question writer in the menu where you can write down questions. And there's also a possibility at the end of the seminar to, so we get all the answers in a file, and we will answer the questions individually after the webinar. So we will give you mainly an overview of what's possible, especially in combination with iSystem tools, and how our interface is used to integrate this tool set from iSystem in a continuous integration process. And Alesh will give you at least an idea how to prepare such an environment, how the testing is done with our tools, and the API is used. And this is the outcome of the webinar.
Yeah, welcome to our webinar. What is today's agenda? Firstly, I will make short introduction of continuous integration. Next, I will briefly present the iSystem tools and software applications. Then I will describe a procedure how to generate JUnit compliant Python test script used for continuous integration. Next, I will briefly present the Jenkins installation procedure for Windows 10. And at the end, I will describe how to create Jenkins job and how to configure this reporting. So let's start. So what is continuous integration? It is a software tool that basically checks if it is possible to build a software project. There are several continuous integration software available, some running locally and some running on the clouds. Most of them are open source. A developer submits his code to repository, either local or hosted on the cloud, when he finished making changes. A continuous integration server, for instance, Jenkins, Buildbot, or Bamboo, checks out a copy from the repository and then attempts to build the project. If it is able to build successfully, we get a pass, otherwise we get a fail. However, if we want, the continuous integration tool can do much more. We can add a unit or a system integration testing after the build process passed successfully by adding a development tool such as Blue Box on chip analyzer and a target microcontroller board. Our continuous integration can execute a test on our target ECU. Doing so, we can check if the compiled code could be executed on the target CPU. Firstly, we can prepare so-called smoke test. This software test comprises of non-exhaustive set of tests that aim at ensuring that the most important functions work. The result of smoke testing is used to decide if a build is stable enough to proceed with the further testing. Jenkins is one of the most popular automation server for continuous integration. It is a free open source software program based on Java. It can run on most popular operating systems such as Windows, Unix-like operating system including Linux and Mac OS. We can easily install and configure it via its web interface, which includes building help and error checking. Plugins make Jenkins really powerful and adaptive automation tool for development and testing. With plugins that are in hundreds in number, we can really enhance the integration into existing environment and the power of the Jenkins as a test automation tool. We can extend the functionality of the Jenkins without creating our own version of Jenkins, but with the extension of a functionality. Our added functionality will be always there as an extension to the new core versions of the Jenkins. With the Jenkins, it is really easy to distribute work across multiple machines, helping faster builds, tests, and deployment across multiple platforms. With the use of continuous integration, we can find bugs and stabilize new software sooner. All this can increase cost saving and application quality. An automated testing with continuous integration improves a transparency of the software development and also a developer morale. Besides these benefits, an automated testing with continuous integration has a challenge. We need to prepare new tests for testing a new software functionality. iSYSTEM tools are built around the IC5700 debugger. The specialty is the expandability of debugger with several add-on modules. On the picture, first is CAN-LIN add-on module used for network analyzing. We can analyze CAN-LIN buses and inject messages to the buses. ADIO add-on module is used for analyzing analog and digital IOs and driving the target with signals. ActiveProbe is special debug and trace connector for high bandwidth tracing and profiling of controllers such as Infineon Aurix and ARM Cortex. If more than one add-on module should be connected, the hub expands the ports from 1 to 4 pieces. At the back of the hub is special Ethernet port used for the enabling synchronous debugging and trace with 2 iSYSTEM debuggers on 2 CPUs on 2 different ECU targets. On the left is a screenshot of the WinIDEA IDE. It has some advanced features for speed up debugging. The real power of WinIDEA can be found in its analyzer, a program and data trace visualization tool of trace, code coverage, and profiling measurement. It also supports real-time operating system awareness. iSYSTEM can offer some advanced tools for timing analysis to cover arbitrary timing scenarios like AutoSAR event chains. Trace Analyzer can trace and profile signals on iOS, the CanLean messages with the use of add-on modules. Our testing approach reuses the blue box debugger together with a target ECU. WinIDEA project contains the configuration for the debugger and target CPU. The automation of the debugger together with IOM modules, some APIs are used. iSYSTEM Connect, iSYSTEM Test, and iSYSTEM FNet. We can create tests with a test idea application, or we can write scripts on our own. We can also use an internal test idea script generator, and we can generate out of test idea a completely JU compliant Python script that can be used for the continuous integration without any additional work. We can download from iSYSTEM webpage the 3 iSYSTEM APIs for automation and testing. iSYSTEM Connect API is used for automation of the debugger. iSYSTEM Test API is used for testing. We can create unit, system test, and test reporting without any instrumentation. iSYSTEM FNet API is used to automate CanLean and ADIO add-on modules. With this, we can generate stimulus for the ECU during the continuous integration testing. iSYSTEM Test IDEA is an application for embedded software test. We can prepare unit and system test, and we can use stubbing of embedded function by using Test IDEA GUI. We can inject faults. With the Test IDEA application, it's possible to create several test suites. We can measure coverage and timing of execution with the iSYSTEM trace feature. Test IDEA can create several reports with results of testing and other measurement. Test IDEA reporting can comply the JUnit format. The JUnit XML The JUnit testing framework introduced an XML file format to report the test suite execution. The JUnit XML report can be processed by the Jenkins. In the case of writing a standalone Python test script by using iSYSTEM APIs, we need to take care that the test report complies JUnit XML format. We can use also 2 Python modules, UnitTest, also known as PyUnit, or JUnit XML. On this slide, we can see some snippet of the JUnit XML format with the XML text with descriptions. Here we can see a snippet of the test report in JUnit XML format. There were 9 tests executed, of which 4 tests have terminated with the exception error, 1 test has failed, the test result evaluation failed, and of course 4 tests have passed. After knowing some details about test IDEA features and continuous integration with Jenkins, we can proceed with the generation of the Python test script by using test IDEA. First, we need to prepare several unit and system tests with the test IDEA. Later, we can generate Python test script. When generating the Python script, we need to define the path to the iSYSTEM Connect DLL, and we need to check that the test report will be in JUnit format. Test IDEA script generation supports importing of external Python modules, so we can include Python code for driving other external devices if they have Python module for automation. After generating the test Python script, we need to prepare the Jenkins server. Here we have a couple slides on how to install Jenkins server on the Windows 10. We can find on the jenkins.io webpage the documentation how to install Jenkins on numerous operating systems, including the documentation and the installer for the Windows. After downloading and running the Windows installer, we just need to follow the installation instructions. After the installation is finished, we need to open in a browser localhost on the port 8080. After Jenkins page is displayed, we need to unlock Jenkins with initial password and select a configuration with suggested plugins. Next, we need to complete the creation of an admin user. Then, we can start using Jenkins. Before starting with the creation of the Jenkins task, we can have a short overview what we can prepare with the Jenkins. We can create a pipeline or freestyle project. Jenkins task can run on a master or on a client node. We can run Jenkins task on the client PC while the Jenkins server runs on the server host. We will prepare Jenkins continuous integration job and we will add a step with execution Python test script. Jenkins will execute the Python script and run a test with the use of iSYSTEM debugger on the target ECU. Creating a new freestyle project requires clicking on the new item from the Jenkins menu. Then we need to enter the name and click on a freestyle project. We will skip the application building step with this presentation. After that, we need to add the execution of the Python test script in the freestyle project build configuration. We need to create an execute window batch command for running the Python test script. At the end of running the test script, the JU unit XML test report is generated. This report needs to be published in the post-build actions. The name of the test report was defined and stored in test idea configuration. We need to add .junit.xml extension to the report file name for publish JUnit test result report setting. The test idea can also generate HTML test reports and coverage measurement HTML reports. These reports can be included into publish HTML reports or the freestyle project configuration. After saving the configuration on the freestyle project, we can manually start the Jenkins test by clicking on the Build Now. Of course, Jenkins can be configured to run tests at a given time. After running test, we can check the test results. After a couple of test runs, the Jenkins also displays the test result trends. Next, we can also check the test idea HTML test report that was included into the Jenkins reporting. With the browser, we can also browse the coverage measurement that was measured by the iSYSTEM trace analyzer. We can check with the browser what lines and branches have been executed or not. The coverage measurement statistic is also part of the coverage report. When creating Jenkins pipeline job, the configuration is a bit different. We need to prepare batch file for the Python test script execution. This is then included into pipeline stage of the pipeline Groovy script. The test and coverage reporting are added at the next stages of the pipeline Groovy script. At the end, I would like to mention that we can find on iSYSTEM webpage www.isystem.com additional help, documentation, and trainings on how to prepare test idea testing and on debugging with a Win idea. Now, I will finish my presentation. I will give back the word to the moderator.